How to calculate the design shear resistance of the connection shown. We will assume that the steel grade is S275, and bolts are M20 grade 8.8. First of all, we need to check the bolt's spacing and edge, end distances. The following conditions need to be met. For grade S275 steel with plate thickness equals 10 mm, the design strength would be 275 Newton per square millimeters, epsilon equals 1. Hence, all bolts spacing and edge, end distances to bolts are satisfactory. Next, we need to check the shear capacity of bolt group. For M20 grade 8.8 bolts, tensile stress area equals 245 square millimeters, and shear strength 375 Newton per square millimeters. The shear capacity of single bolt equals tensile stress area, multiplied by shear strength. We need to watch our units here. Square millimeters, multiplied by Newton per square millimeters. So divided by 1000 to get our value in kilonewtons. This gives us a value of 91.9 kilonewtons. Therefore, the shear capacity of bolt group is 8 times 91.9. This results in value of 735 kilonewtons. Following up, checking the bearing capacity of the connection. Bearing capacity of bolt is given by bolt diameter 20 mm, multiplied by thickness of end plate connected part, which is 10 mm, multiplied by bearing strength of the bolts, which is equal to 1000 Newton per square millimeters for grade 8.8. Therefore, the bearing capacity of bolt equals 200 times 10 to the power of 3 Newton. Divide by 1000, this gives us a value of 200 kilonewtons. Note that the end plate is thinner than column flange, and will therefore be critical. Bearing capacity of end plate is given by bolt diameter 20 mm, multiplied by thickness of end plate 10 mm, multiplied by bearing strength of end plate, which equals 460 Newton per square millimeters for steel grade S275. This gives us value of 92 times 10 to the power of 3 Newton, divide by 1000, we get 92 kilonewtons, which it should be equal or less than 0.5, times end distance 50 mm, times end plate thickness 10 mm, times bearing strength of end plate 460 Newton per square millimeters, which is 115 kilonewtons. Hence, the bearing capacity of connection equals 8 multiplied by 92 kilonewtons. This results in a value of 736 kilonewtons. Next, checking the end plate shear strength. Bear in mind, shear area equals 0.9 times the net cross-section area of the plate, which is 10 mm times open bracket, length of the plate 460 mm, minus the number of the bolts 4, times the diameter of the bolt holes 22 mm, close bracket. This gives us a value of 3,348 square millimeters. Shear capacity assuming single plane of failure is 0.6 times design strength 275 Newton per square millimeters times shear area 3,348 square millimeters. This gives us a value of 552.4 kilonewtons. Shear capacity assuming two failure planes is 2, multiplied by 552.4 kilonewtons, giving us 1,104.8 kilonewtons. Last but not least, checking the local shear strength of the beam web at the end plate, which equals 0.6, multiplied by design strength 275 Newton per square millimeters, multiplied by shear area 0.9, times the web thickness 10.6 mm, times 460 mm. This results in a value of 724 kilonewtons. Finally, weld strength check. Fillet weld of 6 mm provided. Hence leg length equals 6 mm, and the throat size would be 0.7 times 6 mm, which is 4.2 mm. Assuming electrode strength equals 42 Newton per square millimeters, the design strength would be 220 Newton per square millimeters. Working out the effective length of the weld, which equals the length of the plate 460 mm, minus 2, times 6, multiplied by 2. This gives us a value of 896 mm. Hence, design shear strength of weld, equals design strength 220 Newton per square millimeters, multiplied by throat size 4.2 mm, multiplied by the effective length of the weld 896 mm. This gives us a value of 828 kilonewtons. Therefore, strength of connection is controlled by shear strength of beam web, and is equal to 724 kilonewtons. Thanks for watching. We hope you found some useful tips. Check out our website at structuralengineercalcs.com. Please like and subscribe, and let us know what would you like to see next. The human footprint is a masterpiece of engineering and a work of art. Stay safe. Goodbye, and see you soon.